Hello everyone, my name is Rahul Pawar from Department of Electronics and Communication from STM CET Dharwad. So today we are going to discuss about Hamming code, its error detection and correction methods. So what is a Hamming code? Hamming code basically is an encoding technique which is used to encode data and then later on it is used to decode at the receiver side. The Hamming code method is a network technique designed by R.W. Hamming for damage and error detection during data transmission between multiple network channels. The Hamming code method is one of the most effective ways to detect single data bit errors in the original data at the receiver end. It's not only used for error detection, but it's also for error correction in the data bit. Let us take an example. Suppose the number of data bits is 7. Then the number of redundant bits can be calculated by using the given formula. So here the number of redundant bits is equals to 4, which you call it as parity bits. These 4 bits will be added to the data bits and then it will be transmitted to the receiver side. It can be done by two types, even parity bit and odd parity bit. In the case of even parity bit, for a given set of bits, the number of ones are counted. If that count is odd, then the parity bit value is set to 1, else it will be set to 0. And in case of odd parity bit, if the bits number of ones are counted, if that count is even, the parity bit value is set to 1, else it is set to 0. We have this generator matrix, which is composed of identity matrix and parity matrix as shown in the figure. This matrix operation is simplified into mathematical equations and then is used for encoding. For encoding, let us take an example. Suppose the number of data bits is 7 and the number of redundant bits is 4. Therefore, the total number of bits will be 11. Those 4 redundant bits are position corresponding to the power of 2 raised to 1, 2, 4 and 8 as shown in the figure, that is D1, D2, D4 and D8. The parity bits, that is at the position P1, P2 and P3, are calculated by the operation as shown in the figure. So after the operation with the even or odd parity, we get to know that the value of P1 may be either 1 or 0. These are called the parity bits and they are stuffed together with the data bits and are ready to be sent to the receiver side. The received data is then have to be decoded. So sometimes it happens that some of the bit in the encoded data gets altered and these may cause an error. So a decoding technique is used. So here for all the parity bits we will check the number of ones in their respective bit position. So here we have a error bit at number 6. So how will we find that? For R1 bit 1, 3, 5, 7, 9, 11, we can see that the number of ones in these bit positions are 4 and that's even, so we get a 0 for this. So same for the R2 bits 2, 3, 6, 7, 10, 11. We see that the number of ones in these positions are 5 and that's odd, so we get 1 for this. So and so on we do it for R4 and R8. And finally the bits give the binary number 0110, which corresponds to decimal representation is 6. So therefore we get to know that the 6th bit is error. Thus the bit 6 contains an error. To correct the error, the 6th bit is changed from 1 to 0. In this case it has to be changed from 1 to 0. Now let us demonstrate the same technique with C code.